football helmet and said, okay, let's talk. And I said, stay.
Hey everyone, welcome to today's lesson about graphing linear inequalities. A linear inequality is almost identical to a linear equation, except the equal sign has been replaced with an inequality symbol. So we'll graph them just the same. I'll either use slope or my intercepts. The difference comes in when you look at the inequality symbol. If it's strictly less than or strictly greater than, I'm going to use a dashed line. If it's less than or equal to or greater than or equal to, I'll use a solid line on my graph. I will shade above or below the line to show all solutions that satisfy the inequality. Similar to when we graphed inequalities on the number line, we shade all values that satisfied. Well, we'll do the same thing on the coordinate plane. We'll shade above or below the line. To determine where to shade, we'll use what's called a test point, and we'll talk about that in our first example. So let's take a look at the first example. I've got y is less than or equal to 2x minus 3. I can see that this is in slope-intercept form. I've got a y-intercept of negative 3, so I'll put that point down there at negative 3. And I've got a slope of 2 over 1. So I'm going to move up 2 and then to the right 1. Since this is less than or equal to, I'll connect those 2 points with a line, and that'll be a solid line. Whoa, pretty thick line. Now I have to determine where am I going to shade. All right, I'm going to pick a test point. I think the easiest test point to pick is 0, 0. All right, I'm going to plug in the point 0, 0 to the inequality. If that point satisfies the inequality, I'll shade on that side of the line. If it does not satisfy the inequality, I will then shade on the other side of the line. So let's try it. 0 less than or equal to 2 times 0 minus 3. 0 is less than or equal to negative 3. That is not a true statement. So I'm going to go on the other side of the line to do my shading. All the shaded values represent potential solutions to this inequality. All right, example number 2. In this example, I am now in standard form. Since I'm in standard form, I'm going to want to use those intercepts to graph. While I'm finding the intercepts, you can pretend like this inequality is an equal sign. So watch this. I'm going to plug in 0 for y. That leaves me with 4x equals 12. So x equals 3. I'll put my point at 3 on the x-axis. Now I'll plug in 0 for x. I'm left with negative 3 equals 12. Y is equal to negative 4. So I go down here to negative 4 on the y-axis. All right, since this is strictly greater than, I need to use a dashed line. So I'll do my best here to make a neat dashed line, and then we'll have to pick a test point to determine where to shade. Like I mentioned before, 0, 0 is a great test point. So let's plug in 0, 0. So 4 times 0 minus 3 times 0 is greater than 12. So 0 is greater than 12. That is not a true statement, so I will shade on the opposite side of 0, 0. There we have it. Now, this dashed line means that points that lie on the line are not included in the solution set. All right, let's look at a couple more examples. For each of these examples, I will show you how to graph using the intercepts and slope-intercept form. So first, the intercepts. All right, if I plug in 0 for y, I've got 0 minus x is less than or equal to 3. So negative x, and remember when I'm using these intercepts, I can pretend that's an equal sign, equals 3. So x equals negative 3. I'll put a point at negative 3. All right, plug in 0 for y, or excuse me, plug in 0 for x. So y equals 3. All right. The inequality has an equal to bar, so I can use a solid line. There we have it. Now I have to determine which test point I'll use. I'm going to use that point 0, 0. So 0 minus 0 is less than or equal to 3. 0 is less than or equal to 3. That is not a true statement. So I will now be shading on the opposite side of 0, 0. Now, what if I wanted to use slope-intercept form? I need to get y all by itself. So to do that, I would go ahead and add x to both sides. In blue, I'll write the equation in slope-intercept form. It would be y is less than or equal to x plus 3. I would have started at 3 and then moved my slope up 1, over 1, up 1, over 1. You can see that all these points lie on the same line. So either way will work. Let's look at the next. First, I'll use my intercepts. All right, if I plug in 0 for x, I'm left with 2y is greater than negative 2. I would divide both sides by 2. Y is greater than negative 2, so at negative 2 is where I'll put my point for the y-axis. Now, plugging in 0 for y, I get 6x equals negative 2. So x equals negative 1/3. Now, this isn't as nice, but it can still work. I'll put my point just past 0 to represent negative 1/3. Now, since this was strictly greater than, I have to use a dashed line. Now, I apologize, it's going to be a little bit sloppy, but you can see that line right there. Now, what happens if I used slope-intercept form and I solved for y to find a slope and an intercept to graph this line? So to do that, I would first subtract 6x. So 2y is greater than negative 6x minus 2. I would then divide everywhere by 2. So y is greater than or equal to negative 3x minus 2. All right, now I can see I would start down at negative 2, and then I would move my slope down 3, 1, 2, 3, over 1. Okay, I'm on the exact same line. All right, now we have to determine where to shade. Let's use that test point 0, 0. All right, if I plug in 0 for x and 0 for y, I end up with 0 is greater than negative 2. That is in fact a true statement, so I'm going to shade on the same side as 0. So I'll be shading up here. All right, folks, now it's your turn. Try the two on your own questions and then check your answer. All right, you should have seen that this is in slope-intercept form, so I can go ahead and put a point at 5 and move my slope up 1 over 2. I'll be connecting this with a solid line since I have the or equal to bar underneath. Now I need to determine where to shade. So I'm going to pick that point 0, 0, and I get 0 is less than or equal to 5. That is a true statement. So I'm going to shade everything on the side of 0, 0. So everything below that line gets shaded. All right, last one. Again, we're in slope-intercept form. So I'm going to put a point at negative 4. My slope here is negative 1, so I'm moving down 1 and then to the right 1, down 1 and to the right 1. I do not have the or equal to bar, so this will be a dashed line. I then need to use a test point to determine which side to shade on. I'm going to use that trusty test point of 0, and I get 0 is less than negative 4. That is not a true statement, so I'll be shading on the other side. Need to be shading down here. There you have it, folks. Hope you learned a little something about graphing linear inequalities. Come to class tomorrow ready to work.